continue our section C. Okay, so here will be part 1. Okay, all the question will be before 2013. The question here will be between 2005 to 2012. Let us discuss the question number 1. So this is the question about 2005. Is similar to current system, which is section C. Okay, so let us read the question together first. Okay, as scheme of reaction is shown below. So here we have X and become Y and release the chlorine gas. Okay, and here we have another equation. So Y we have with hydrochloric acid. Okay, become tetrachlorobromine ion. Okay, so the question asking you to identify what is the X. Okay, and then discuss the chemical properties. Second, compound X is oily liquid while compound Y is wine solid. Explain the different physical state of the two compounds. So here, the first equation, you can see a triangle here. So that means we have to discuss about the thermal stability. Okay, sometimes we don't know what the question are going to ask, but from the information from question, you can try to relate what is the reaction are going to discuss. So here will be related to thermal stability. And then the second, you can see here we have the complex ion form. Okay, and here the information given is lead tetrachloride. Right, okay, so means we have to discuss about the group of the stability for tetrachloride here. Okay, so we get from this information and we try to relate okay, what is actually we need to discuss. Okay, so here see the question asked about the lead tetrachloride. So we focus for this part. Okay, so the general action, heat of the action for group 14 tetrachloride already discussed from carbon to lead. Okay, so this question we focus on the lead tetrachloride. Okay, so here you can see partial decomposition at room temperature decomposes on the slight warming to form lead to chloride and release the chlorine gas. Okay, so the reaction will be here, the equation. Okay. Okay, so there is more revision at your section 4.9.3 here. So why the lead tetrachloride will be easier to decompose? Okay, because it is a simple covalent molecule. Okay, as it is a large size of molecule, atom. So the bond between lead and chlorine is longer and weaker, so it will be easy to be break up when heated. You can see the segment decomposition about the lead tetrachloride is same with the equation, first equation here. So that means the X will be lead tetrachloride. So if we follow the equation, this equation. So we are quite sure that the X will be lead tetrachloride, but the question is 3 marks. You have to give the chemical properties. So the chemical properties for the first, you can discuss the thermal stability. So the decomposition of the lead tetrachloride to become lead to chloride and release the chlorine gas. So this will be the second mark. First mark, you identify the X as lead tetrachloride, and then second, you give the chemical properties with the decomposition. And then the second, okay, so the first answer for X will be lead tetrachloride, and the second mark, as I mentioned, we can just give the composition chemical properties for lead tetrachloride. Okay, so that means it will be changed to or form the lead to chloride, which is more stable and in ionic compound, and release the chlorine gas. And the second, you can look at the information here is related to the formation of complex ion. So all the answer given here, you actually can get from your question. From the revision of section 4.8.3, okay, so all the group 14 element except the carbon can form complex ion. Okay, so example here, we have the list here lah. Okay, so why they can become complex ion? Because they have the empty d orbital to expand their valency, okay, from 4 to 6 lah. So that means another chemical properties you can discuss here will be the lead-2 chloride can dissolve in the concentrated hydrochloric acid to form complex ion. Okay, so that means this question is actually totally you can get from your equation, okay, which is given by the question. So that means this is considered as an easy question, okay. So you don't need to think what is the chemical properties you have to discuss. You can straight away get two information from the question, which is the heating process, the decomposition of the lead tetrachloride, and the formation of the complex ion by the lead-2 chloride. 3 marks will be get with this answer. So the next will be another 2 marks now, okay? Okay, so compound X is an oily liquid while compound Y is a white solid. Explain the physical state of 2 compounds. Okay, so you can see X will be in liquid form, so Y is in solid form. So that means we have to discuss the bond, okay, bond between the compound X and Y now, okay. So here is quite related to the stability of the oxidation state between 2 and 4. So you can see +4 oxidation state of all element group 14s are covalent. So that means that the X, which is in liquid form, we already know that there is a lead tetrachloride, and they are all +4 oxidation state in the group 14 is in covalent bond. And all the XCl bond is covalent bond, so the X is referring to the group 14 now. And the intermolecular forces between the group 4 tetrachloride molecule will be weak van der Waals. So that means the X will be weak van der Waals, okay, which is attracted between the molecule. While for the lead-2 chloride, okay, will be in ionic form, okay, because the lead, which is in bigger size, will be more stable in +2 oxidation state. So that means that from the +2 oxidation state, the bond will be changes from the covalent to the ionic. So here, this is the revision part, which is important for this question, okay. So actually, this is very simple. The lead tetrachloride will be in covalent bond, but there are intermolecular forces will be between the molecule, which is in weak van der Waals forces. So that means will be weak lah. While for the Y will be in the ionic bond. Okay, so the first X will be simple covalent compound with van der Waals forces between molecules. So that's why the X compound exists in the liquid form. Okay, while the Y compound is in solid because Y is an ionic compound which has a strong ionic bond. So this will be 2 marks. First mark for the X. Second mark for the Y. You have to give the structure and the force. So you just add on which information you not stated in your answer. Total 5 points for this section. Okay, and then the next, okay, so question number 2. So you can see this is a question 2007 and will be similar question at your section C lah. Okay, and this is also one of the questions we have already discussed and also considered popular and asked again at section B. We already discussed, which is come out with almost same question regarding the acid and base factor on their oxide. Okay, so So this one you can refer back to your notes again. Okay, section 4.10.1 and 10.2. Okay, so here what's the importance information here will be the table. Here we will see the acid-base factor only. So from here you can see that with the monoxide, okay, which is in the cluster oxidation, okay, so the carbon monoxide, silicon monoxide will be in neutral. Okay, here 4 marks. The first mark is given by this, okay, and then you have to also stat the acid-base factor for germanium monoxide until the lead oxide and monoxide here. So they will be in amphoteric, okay, because they are giant ionic structure with covalent factor, so will be in amphoteric, so will be second mark. Okay, and then the second you have to discuss about the acid-base factor for the group 14 dioxide. So here this is very clear that the carbon dioxide and the silicon dioxide will be acidic, and the germanium dioxide, tin dioxide, and the lead dioxide will be amphoteric. Okay, so you get another 2 marks here. So total 4 marks. Okay, so if no problem, I go to our next question. So this one is quite easy. Okay, you just need to memorize. So what is the acid-base factor for monoxide and also the dioxide for the group 14? So I see this type of question, especially the acid-base factor on their oxide is always come up. You will see more questions regarding this later on. Here actually we have another more information you can actually get from the table at your notes. So you can see from here the +4 oxidation state is more acidic compared to +2. Okay, you can see +2 oxidation started from neutral to amphoteric, while for the +4 oxidation will be from acidic to amphoteric. So here is one of the extra information. Okay, so you can add on, because as I mentioned, we're not sure what is the marking scheme answer, right? So we can add on more than 4 points. Okay, so here you can stat +4 oxide are more acidic than +2 oxide. And one more here, you can see when the element, okay, go down from the group 14 carbon to lead, okay, so the acidity will be decreased and become more basicity. So that means you can add on another point here. That means you guys, let's say with the marking scheme give this type of the answer, so that means they will give the monoxide acid-base factor will be 1 mark already, and then here will be second mark, here will be third, here will be fourth. So I referring few marking scheme. Okay, I see that sometimes they give the answer very short, which is just mention the acid-base factor for the group 14 oxide. Okay, but I referring to another set of the marking scheme, but with different years. So I see that this is come out another 2 answer. So that means that I advise you to give fully this 6 points for 4 marks question. Lead 4 oxide is dark brown, solid. Okay, so when lead 4 oxide is heated with the aqueous solution of a manganese 2 salt in the presence of the excess nitric acid, the reaction takes place as follows. Then how lead 4 oxide react and state what is observed. So from here, so 2 answer you have to give. One is how lead 4 oxide react, and you have to give another one is the observation for the reaction. Then you will get 4 marks. So not the 4 marks all is regarding the reaction, but you have to give the observation also. So from here you can see that the reactants, which is ion manganate 2 plus, will be oxidized, okay, and the oxidation state will be +7. And then the lead will be changed the oxidation number from +4 to +2. So that means here there is oxidation and reduction occur. So we know as a redox reaction, right? Okay, so we will discuss the reaction regarding the redox reaction. So the first three marks will be regarding the how lead oxide react. Okay, so this is a redox reaction. So the lead to oxide undergo reduction. Okay, and lead 4 oxide, okay, is an oxidation agent. So you get to discuss this. And the oxidized manganese to oxidation state from +2 to +7. So that means the iron manganate 2 plus is a reducing agent. Okay, so that means we have to discuss the redox reaction and what is the process occur for the lead 2 oxide, which is the reduction, and together with the oxidation agent. And then another one will be for manganese. You have to give the oxidation state, and E act as a reducing agent. Okay, and the last mark will be given for your observation, which will be change the solution color from light pink to purple. So you'll get 4 marks for the reference answer here. So then C. Okay, so the repeating unit of the type of silicate is iron, right? Okay, so silicon 2O5. Okay, so this one is similar to the section B discussion for our last discussion. This is regarding the silicate, okay, at year 2017, repeating test, okay. So draw the structure of repeating unit, name the substance, okay, and then give the use, okay, use of the substance here. Okay, so this is a repeating unit. So this is a type of silicate with repeating unit given here. Okay, so here the repeating unit already given, so you have to draw. And this is regarding the revision at 4.17.3 sheet silicate. Okay, so this one actually I also discussed already for last discussion. Okay, so here is a structure for the sheet silicate. So as I mentioned, you have to memorize the factor. So sheet structure is formed, and the SiO4 4- unit linked together by sharing 3 oxygen. And the empirical formula will be this, so which is meet our question here. So we are sure that the repeating unit given by the question with this formula is silicate, sheet silicate. Okay, and we have also need to memorize the physical character. So sheet silicate are soft and slippery, okay, because they are bonded with the covalent bond. But for the individual sheet, that is held by the weak van der Waals forces. So example, you also have to memorize also. So if you memorize this all thing, you can do this question. Okay, so first, with this empirical formula, so you have to draw the structure. So that means you have to memorize the structure here. Okay, so here we have silicon 2 will be this. And then the oxygen 5 will be this. Here we have behind we have the silicon. So this will be another unit. So this is first mark. And then you have to name the substance. You need to give the use of the substance. Okay, so we have to give kaolinite substance which under this sheet silicate. So here we have many answers if according to your notes. You can give kaolinite used for making porcelain, utensil and pipe. Mica used as electrical insulator in high voltage electrical equipment and in capacitor and others. So here just need to give one name of substance. We have the same structure and give the uses or application. Okay, all will be at your notes, page 18, section 4.17.3. So this is a straightforward question, but you have to memorize. So the next question, number 3. So it's a question in year 2009. Okay, so the standard enthalpy change of the reaction for carbon and lead are as follows. So using the respective value for this H enthalpy, explain the relative stability of the oxidation state of the element in group 14 and periodic table. So that means we have to relate the H enthalpy here to the oxidation state. So as we know that for the group 14, so there will be only two oxidation state, which is +2 and plus 4. Okay, so again, you have to discuss about the +2 and +4 stability. Okay. Okay, so from this information, first, the positive enthalpy showing that the +2 state of carbon is less stable. Okay, because we require more energy we absorb more energy so that we can form the carbon monoxide. So that means the equation here will tends to become more less stable. So that means actually the carbon will be more stable in the +4 oxidation state. And when come up to the negative, that means the energy release will be more stable. So that means this equation will be more stable to form the lead-2 oxide. So that means the lead will be more stable in +2 oxidation. So you need to try to relate between the exothermic and endothermic to the stability of the oxidation state here. Okay, so here the reference answer for the positive H enthalpy indicate that, okay, with +2 oxidation of the carbon will be less stable. So here the carbon monoxide, the carbon here will be have +2 oxidation. So that means the reaction for this equation will be not stable because you require more energy, which is more endothermic. While for the second equation, which showing the negative enthalpy value, showing that the equation here will be more stable to form the lead-2 oxide. So that means the lead will be more stable in +2 oxidation compared to +4 oxidation. Okay, so this will be first 2 mark. Okay, so again, we can relate to the graph which we have already learned at the section 4.8.2 here. Okay, so you can see from the graph, okay, so descending of the group 14, which is from the carbon to the lead, okay, so the stability for the +2 oxidation will be increased, while for the stability of the +4 oxidation state will be decreased. Okay, so why we have to discuss what happened and why this phenomenon occur. So you have to relate that to the inner pair effect. Okay, as we know that the lead has a bigger atom and consists of the orbital, suborbital 4. Okay, so the electron in the 4f orbital give an ineffective shading effect. So the attraction of the nucleus, okay, to the s electron in the lead will be higher. So there will be only 2 electrons from the p orbital will be bonding, so that the lead tends to be more stable in +2 oxidation state. So you have to discuss the reason. Okay, so first 2 marks you can just get from the information given by the question, but you have to relate which is stable. And then third mark and fourth mark will be theory discussed regarding the relationship between the enthalpy H to the stability of the element. Okay, so that means that very simple, you can just see for the value positive will be endothermic, will be normally less stable. So that means to form carbon monoxide will be less stable. So carbon monoxide will be in +2 oxidation. So that means +4 oxidation state for the carbon will be stable than +2 oxidation state. Then this will be vice versa for the lead. Okay, here showing the negative value. So this will be the exothermic reaction, which will be more stable to form lead-2 oxide. So as our theory, the lead which is bigger size will have the inner pair effect, so that the 2 electrons at the p orbital will be more ready to form a bond. So they'll be more stable at +2 oxidation. Okay, so the next will be with the add of the diagram, describe the structure of diamond and graphite. Okay, so this one, we have touch and go information at 4.11.1 here. The more detail actually at your Sem 1, chapter 4 already. Section 4.4 solid. Okay. Okay, so here the information we get from our Sem 2 is not so many other information. So it's only 3 allotrope of carbon. They are diamond, graphite, and fluorine. Okay, so here we have to discuss the diamond and graphite only. So you have to draw the structure. So this one you can get from notes Sem 1, chapter 4. So the diamond will have this structure and this is a graphite. Okay, so each diamond and graphite have giant covalent structure. So that means 2 marks will be given for the diagram, okay? And then you have to give the explanation. So in diamond, each carbon undergo sp3 hybridization and is covalently bond to 4 other carbon in tetra manner. So that means for diamond, there will be no any extra delocalized electron to become more conduction. Okay, so that means the diamond is actually non-conductor. Okay, while for a graphite, so the C atom undergo sp2 hybridization. Okay, so that means if let's say the question asking you regarding the conductivity, so the graphite will have conduction compared to diamond because of the bond sp2 compared to sp3 for carbon and for diamond. So that the sp2, which is for graphite, will have the extra delocalized electron. But here we don't discuss about the conduction. Okay, so you just need to explain the structure. So you have to give graphite EC undergo sp2 hybridization and is covalently bonded with 3 other carbon atom in trigonal planar shape. Okay, and this form layer structure of the hexagonal ring. So it's here. Okay, and this layer will be hold with another layer with the weak van der Waals. So that means here 4 marks. You see the scheme reference answer is so many. It's more than 4 marks already here. So we go to next question. Okay, so what is the relationship between the diamond and graphite in terms of structure? Okay, so this one, same okay. If let's say we're referring to our Sem 2 notes okay, where we have not so many information, but here it can be applied. So diamond and graphite are allotrope of carbon. Okay, they have different arrangement. Okay, they have different arrangement of an atom. Okay, so we go to our question 4. Okay, so again you can see here is a question in 2010. Okay, and also you can see this is a similar question with 2012. We already discussed at section B. So the question is this: the relative stability of oxide of group 14 element of the periodic table are shown in the graph below. So the graph is given. Explain the trends of the relative stabilities of oxide group of 14 elements in group. Okay, in the graph. Okay, so here we have 8 marks. So what we can discuss here. So this one is not answer okay, just a discussion regarding the question. Okay, so from here you can see for the group 14, firstly you have to state the possibility of the oxidation state for group 14 will be only 2, which is 2 and plus 4. And then you can discuss the configuration for the group 14 elements, okay, which is NS2 and P2. Okay, and from here you can discuss why they can appear as a +2 and +4 oxidation. So let's say in +2 oxidation, that means that there are only 2 electrons will be bonding, okay, so which is at the p orbital. So you have to discuss when only the 2 p electrons are used in bonding, the oxidation state of element will be +2. Okay, so this one will help you to elaborate. So firstly, discuss the general. the oxidation state with +2 and +4. Second, discuss the configuration, which is NS2 and P2. So why can become +2 oxidation? Because there are only 2 electrons at orbital P, okay, can be bonding and form the oxidation state element in +2 oxidation. And to become +4 oxidation, that means all S orbital electron and the P orbital electron will be involved in the bonding. Okay, so involve S and P orbital, S and P orbitals electron. So here only we have only how many marks here? 4 to 5 only, but the question asking you to give 8 marks. Okay, so that means we need to explain more theory which you have actually already learned in the section 4.8.2. Okay, so the question asks you regarding oxide, so you have to discuss more answer with oxide, which is the mono oxide and the dioxide. Okay, so generally you can get 4 marks without discussion regarding the oxide of group 14. So that means that another 4 marks you have to give the discussion regarding the oxide of the 14 element. Here, again the discussion. Okay, so the first point I already discussed with you just now, you can list out the electronic configuration, and then from here you can elaborate why you can get +2 oxidation and why you can get +4 oxidation. So you explain regarding the how many electron is involved and which orbital is involved in the bonding. Okay, so here we can get about 3 to 4 marks already. So furthermore, you have to discuss in +4 oxidation state, which element will be stable. So here, +4 oxidation state of carbon, silicon, germanium is more stable than +2. Okay, while the lead will be more stable at the +2 oxidation compared to +4. And then you have to give the reason. You see, here will be the theory why the carbon to germanium, okay, or also including the lead, including the tin will be more stable in +4, while the lead will be stable at +2 oxidation. So you have to discuss the size of the lead, which is bigger, and you have to discuss about the 4f orbital electron, which will not offer an effective shedding effect. So that means the attraction of the nucleus to the electron for the orbital 6s will be more. So there will be only 2 electrons will be involved in bonding. So the lead will be more stable in +2 oxidation. So this is all is the discussion which you already learned at your notes. Okay, so let us see together what is the 8 marks given for this question. So we already read, then we have to know what is actually the main point you can apply at your question. Okay, so the first mark will be +4 oxidation state of the carbon, silicon, germanium, and tin is more stable than +2 oxidation state. And then you give the equation. Second mark, you give the equation. Okay, how you can form a +4 oxidation state for carbon, silicon, germanium, and tin. So will be example X, and you give X is what? So all 4 valence electrons are involved in bonding due to small energy difference between S and P orbital. Okay, for the lead, there are 4f orbital is between the 6x and 6p orbital, right? So that means the gap for the s orbital to the 6p orbital will be bigger. Okay, so you have to discuss about this. Okay, so then for the stability of +4 oxidation will be decreased down the group due to the inner pair effect. So what I decided already here. Okay, so the big energy difference between 6x and 6p orbital is due to ineffective shading of 4f electron. So this is also considered as the inner pair effect. So you try to elaborate more so that you can get A marks. Okay, explain more detail regarding the inner pair effect. So further, the fifth reference answer here will be only the two electron and 6s electron will be remain as inner pair because the nucleus will be attract the 6s electron more tightly, right? Okay. So for that, the +2 oxidation state is more stable than +4 oxidation state. Hence, that 4 compound are good oxidation agent and is reduced to black 2 oxide, which is in ionic compound. So that means here you see, when we need to elaborate more to get more marks, you have to explain the oxidation agent, you have to give the bond also. Okay, but if I say the question only 4 marks, we just elaborate until here already, you know. But when go for more marks, you have to explain more. Okay, so this is 8 marks reference answer here. Okay, so we go to next question. Question 5. Okay, so this question is in 2011. Okay, so explain the following statement about the elements in group 14. You see, again, the question asking you about the different oxidation state, right? Okay, and here again asks you about the acid and base property. Okay, so again, but here more mark is involved, okay? So 7 marks. Just now, the marks involved is only 4. So here 7. So we can see together what is the additional point for this question. Okay, so again, for the discussion, you have to referring to again for this table. I think this table is quite easy to memorize. Okay, so you can apply a different question, okay, which asking you about the different oxidation state of the group 14 elements. So here we discuss about the acid and base properties again. Okay, so that means we just look at the acid base. Okay, so here will be the important gases here will be the carbon monoxide and the carbon dioxide. So from here you can see in this table, okay, so the carbon monoxide will be neutral, okay, and the bond will be, the structure will be the simple covalent molecule. While for the carbon dioxide, the structure will be the same, which is also the simple covalent molecule, and also together with the weak van der Waals forces between the molecule. But the difference here will be the carbon dioxide is acidic, right? Okay, so the first carbon can exhibit into oxidation, which is +2 and +4, and form carbon monoxide and carbon dioxide. Okay, so means the two important gases oxide here will be carbon monoxide and carbon dioxide. And then you give the equation for carbon monoxide and carbon dioxide. Then the next, both have the same simple covalent molecule. Okay, so CO carbon monoxide is neutral and react neither with acid and alkaline. So that means no reaction for acid or alkaline. Here you can get from your table. And then carbon dioxide is +4 oxidation state. And it is acidic. So that means it can react with base. When carbon dioxide is acidic, carbon dioxide dissolve in cold, dilute, alkaline to form carbonate. And then you give the equation. 7 marks. So here is answer. First, you must identify what is the gases here. So there are the carbon dioxide and carbon monoxide. So this is two important gases. And then you give the equation, discuss the structure, and then the carbon monoxide is neutral and not react with acid alkaline. Then for the carbon dioxide, it will be +4 oxidation state and is acidic, will react with alkaline to form carbonate. So you give the equation. Okay. This equation you can also give the general one. You can also give CO plus 2OH minus CO3 2 minus you can give general equation like this also. You have to give here will be aqueous lah. Here aqueous also. Here liquid. So this is general. Here is reaction with sodium hydroxide, but generally will be like this. Okay, so next, carbon has higher tendency to catenate compared with lead. Okay, so here is the information I also get from notes lah. Okay, 4.1.1, page 2 is regarding the catenation. Okay, so let us review again on what we already learned at this section. Okay, so catenation is the ability of element to form bond. You see, can form bond between atoms of the same element in chain form. So for catenation to occur, okay, so what is the requirement to catenation occur? So the bond between two elements must be strong. Example, C to C, silicon to silicon, germanium to germanium. So must be strong. So that to make the bond become strong, that means the bond must be shorter. Okay, so how become shorter? So the elements must be smaller. So that means at this question, the question asking you the tendency of the catenate compare the carbon to the lead. So that means we have to start to discuss about the size of the element. So as the carbon has a smaller size, so that means the bond between carbon to carbon will be greater compared to lead to lead, due to the length for the lead to lead will be longer and quicker. Okay, so we have to decide to see. If I say you can see the table, so the carbon showing the highest value for the bond energy because it is more stronger compared to the here not give the lead value, lead to lead value, but you can see the trend when go down, the bond energy will be decreased. So firstly, we discuss the carbon had a smaller size and form the strongest M-to-M bond. The M-to-M bond for other elements all are very weak because they have the bigger size of the atom. And then you can see we have another discussion regarding the double bond and the triple bond for the carbon. Okay, so you can see the discussion here. Carbon can also form strong double and triple bond between carbon atoms. Okay, this happens because bond energy for C to C is very high. You can see that the single bonds is 300 plus. When go to double bond and triple bond is getting higher. Okay, so the bond energy is higher. Hence, carbon can catenate to form series of compound known as organic compound. This all information 100% I get from the notes. And the information is not so many, and you can memorize very easily. So here 4 marks, you can give all the points from the notes. Okay, so you can see together with me the answer. So the question asking you about the tendency catenate comparison between the carbon and lead. So firstly, you have to give the size. Okay, so here the first mark given is regarding the definition. So catenation is ability to an element to form bond between atoms of the same element. Okay, so that means if I say you just compare the size, compare the bond to bond length, compare the strengthness of the bond to bond and end to end bond, so maybe you will be only get 3 marks. Because according to this scheme, you have to give the definition. So we have to try give more information now. So the first, give the general, what is the catenation? Okay, and then second, give the size, compare the size of the carbon to the lead, which is the carbon is smallest, and form the strongest M-to-N bond. Okay, you can give the length between the M-to-N bond for carbon, which is shorter compared to lead. Okay, so the lead to lead bond will be weak due to the size is biggest and the length PB to PB bond is also longer. Okay, and then you have to discuss the carbon can form strong double and triple bond between the carbon atom. So if I say you just compare, here you only have two points meet the marking scheme. So another 2 marks you not get again. Okay, so this is a reference answer. So I advise you to write more than 4 points lah. Okay, and then next will be the tin and lead form complex ion. Okay, these 2 ions respectively. However, carbon does not form complex ion. Okay, this one is also the similar question at 2005 section C we discussed just now. Okay, but the question just now not ask you to discuss why the carbon cannot form the complex ion. Just we know the PB, just now the question number 1 can form complex ion. Okay, actually it's due to it has the d orbital. Okay, so again we referring all related info from notes at section 4.8.3. Okay, page number 5. So this is all you learn. So you just need to memorize these 4 sentences. You can apply a different question. Okay, so all groups 14 elements except carbon can form complex ion. I see generally lah. So example, these 4 type of complex ion. Okay, which is except for carbon lah. So in the complex ion above, okay, the central atom, which is silicon, germanium, tin, and lead, make use their empty orbital d to expand the valency from 4 to 6 lah. So here the question asks you why carbon cannot form complex ion. So because carbon do not have the d orbital. No d orbital in its valence shell, so cannot expand its object to accommodate for more than 8 electrons. So you can discuss this. So the reference answer 4 marks here, you see what you read like this. So the marks given maybe is different, right? Okay, so what is the given mark for the scheme? So the first, tin and lead can make use their empty d orbital to form complex ion. Okay, so you explain here first why tin and lead can form complex ion, because they have the d orbital. So the complex ion above, in the complex ion above, so these 2 lah, the center atom make use the empty d orbital to expand their valency from 4 to 6 lah. So that means more than 8 electron can be can form the dative bond here lah. So first 2 discuss why these 2, tin and lead, can form complex ion. And then another 2 marks, carbon cannot form complex ion because carbon in period 2 plus do not have d orbital in its valence shell, so cannot expand its object. So that means maximum can fit on 8 electron only lah. Okay, so cannot form the dative bond together with ion chloride. So that means all actually from the notes lah. You just copy and paste at this question. Okay, so we go to our last question for our part 1, section C, which is the question all before 2013 now. Okay, so titanium and germanium have the same numbers of valence electron. Explain the differences in the electrical conductivity between titanium and germanium. 8 marks. Okay, so titanium not listed in the element group 14. So you can refer back to your periodic table. So the proton number will be 22. So 22, the valence electron here same. Okay, but according to the periodic table, so the titanium is under transaction metal, right? So transaction metal will have the electrical conductivity characteristic. So for germanium, we are very sure because now we are at chapter 5, okay, group 14. So germanium will be a semiconductor. So how we can relate the titanium and germanium regarding the electrical conductivity? So you just need to discuss the conductivity between electrical conductor and the semiconductor. Okay, you just have to modify the notes from the section 4.5, density and conductivity, page 2. So what you learned there, okay, so let us discuss together what you already learned and how we can relate the info from your notes to this question. So density and conductivity increase down the group, reflecting the increasing metallic factor. But here we don't discuss this. I just discuss together what we learned at section 4.5. Okay. So when going down to the group, so from the carbon to lead, okay, so the element will be changed from giant covalent to metallic structure. So the conductivity will be increased. So that means here we learned already from non-metal. Okay, we discussed about the energy gap between the valence band and the conduction band, which is very big. We learned already. So how we apply here. Okay, so that means for carbon, which is non-metal, electron cannot jump from the conduction band to valence band. But we not use this formation for this question. And then B, we learned already silicon and germanium are semi-metal or metalloid, where they have the conductivity between the conductor and insulator, because the energy gap between the valence band and the conduction band is small. So the electron can be jumped from the conduction band to valence band. So we will use this info. The question here will be 8 marks. So we will get some information here, and then we can apply here also. In and lead is a metal, they are conductor. So the presence of the delocalized electron and form the metallic bond. And there is no gap between the valence and conduction band since they are overlapped. So the electron can flow easily from conductor and from conduction band to valence band. So here we will change the information which is tin and lead to titanium. So that means we discussed already. So we just discussed the titanium, both with the germanium have the same valence electron. You give the electronic configuration for your first mark. Okay. And then you can mention that the titanium is a metal, so they are conductor. So you can use the info here already. Okay, so you discuss that there is no gap between the valence and the conduction band since they are overlapped. So the electron can flow through easily the conduction band and valence band, so it can conduct electric. And again, you use B germanium is a semi-metal which have the conductivity between conductor and insulator. So the gap between the both band, which is the valence and the conduction band, is small. So the electron can jump from the conduction band to valence band. And one more thing, we know that the semiconductor, the conductivity will be increased when we increase the temperature, right? So this all information you can get 8 marks already. Okay, so first mark, give the configuration for the titanium, which is this and then the germanium. Okay, both have the 4 valence electron because the question already given you. Okay, so the germanium and titanium have the same numbers of valence electron, which is 4 here. Okay, and then you discuss titanium is a metal, is a good conductor. So you discuss there is no gap between the valence and conduction band electron. So that means the electron can be easily go through or jump from the valence band to the conduction band. So it is a good conductor. See, you can relate what you learned from the notes already. Okay, although the titanium is not listed in the group 14. Okay, and then it gives the germanium is a metalloid. So the gap between the band and conduction band is small. So at high temperature, which I mentioned, semiconductor will have better conductivity. Okay, when the temperature increase. Okay, more electron can be promoted from the valence band into the conduction band. Okay, so electrical conductivity of germanium increase with temperature. Electrical conductivity of titanium will be decreased because conductor, when the temperature increase, the vibration of the electron will be stopping the flow of the electron. So one more, last. Okay, so here B, the main component of glass silicon dioxide. Explain why glass container can be used to store water and strong acid, but not strong alkaline. This one we discussed last lesson yesterday, which is at the section B 2015. So again, this is info regarding 4.15.2. So yesterday we discussed this already. Okay, so silicon dioxide is acidic, so they will not react with acid but react with base, right? So furthermore, we also mentioned that silicon for oxide is chemically inert. They will be only affected by the chlorofluoric acid and concentrated alkaline. So here again, for the reaction with the hydrochloric acid, okay, it will be changed to hexafluorosilicate for complex. But here we not discuss about this now. Same with the question we discussed yesterday now. So but for the concentration alkaline, okay, so the glass will which contains silicon oxide, they are acidic. Okay, you refer to the table here. So it will be react with the concentrated alkaline and form soluble silicate salt. So you give the equation. Hence, the concentrated alkaline should not be stored in the glass container. So this is exactly the same question. But here, yesterday we discussed only 4 marks. Here we have 7 marks. Okay, so firstly, discuss what is the component for glass, which is silicon dioxide, and it has a giant covalent. This is a giant covalent structure with the strong covalent bond between the silicon and oxygen. Okay, so it does not react with water due to it has a strong covalent bond, and not to acid because it is an acid. Yesterday we not give the answer because of 4 marks, but here the scheme given this statement, okay, silicon is an acid, so it do not react with acid because the statement is in the question already. Why do not store in water? Because the silicon dioxide has a strong covalent bond. And why not react with acid? Because it is a acid. So that means that the mark is related to the question. You see or not? Yesterday the question only asking you why not in strong alkaline 4 marks. You can refer back to the same question, section B 2015. But here we have 7 marks. So you have to discuss together with the reaction with water and also the acid. Okay, so the next will be silicon dioxide in glass is acidic. So here you already mentioned the same thing. So silicon dioxide in glass dissolve in hot and concentrated sodium hydroxide to form sodium silicate. So this will be the same point with yesterday. So we just add on another point which is not related yesterday question. But here you have to mention mainly for the stored water and also the strong alkaline. I will finish the part 1, which is all regarding a question 2013. Okay, so that's all for my discussion. Thank you.